Okay, if we take a look at example 1 here on section 4 or 5, we want to show that these two right triangles are congruent using one of these four theorems: side, angle, side, 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 angle, side, angle, or angle, angle, side. Those are our four congruent theorems for regular triangles that aren't necessarily right triangles. And you'll notice right off the bat that this does not fit any one of those criteria, right? We got side, side, angle, which we found out back on the other section. Side, side, angle triangles specifically were not congruent in the general triangle world, right? Now we're getting into a more specific type of triangle, specifically a right triangle. So I have to consider this possibility in the right triangle world. Is this setup possible to confirm that right triangles possibly could be congruent based on this fact, all right? But we want to relate it back to something we already know how to use. Side, angle, side, 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 angle, or angle, angle, side. All we know beyond the fact that these two sides are congruent, these two sides are congruent, these two angles are both right angles, which means they're also congruent. The only other thing we know is that they're right triangles. So what I need to do is I need to use that right triangle idea in order to see if anything else might be true about these two triangles. Right? Are there any properties in right triangles that exist that don't exist in other regular triangles? Any theorems we've learned this year or previous years about right triangles specifically? If the sides are A, B, and C, typically when you look at triangles, angle A is the side opposite side A, angle B is opposite side B, angle C is opposite side C, like that. Just that's how we typically do it in math. And over here, if I call this D, I call this E, and I call that F, right? So what I know is that B and E are equal to each other, C and F are equal to each other, right? Is there any relationship between the sides in the right triangle that we know? That we may have learned this year or previous years? And we were told never ever to forget it, ever, in our entire life?
What did you just ask?
Named after a Greek philosopher. His name starts with the letter P.
I would have said Pythagorean's Theorem.
That's it, Pythagorean Theorem. Way to go. So the Pythagorean Theorem is named after Pythagoras. He's a Greek philosopher, if you didn't know that. Anyway, the Pythagorean Theorem states that in a right triangle, leg squared plus leg squared equals hypotenuse squared. In addition, since these two sides are equal to each other, I could actually call this B also, right? Those are congruent, so their measures are the same. And the same deal here, this is congruent to this, which means this is C, this could also be C, all right? So we have the capacity to use the same letters to represent some unknowns in this picture based on what they're telling us is true. Equal sides here, so these are equal, so I can use the same letter to represent. Equal sides here, use the same letter to represent. Okay. If I apply the Pythagorean theorem in both triangles, on this one here I'm going to get A squared plus B squared equals C squared. Right? I don't know what A, B, or C equals, but I know that relationship's true. One leg squared plus the other leg squared, the two sides making the right angle, equals the hypotenuse, the side opposite the right angle squared. Right? Over here, same idea. If I write the Pythagorean theorem, this one I'm going to get D squared plus B squared equals C squared. Right? Leg, hypotenuse. Leg squared plus leg squared equals hypotenuse squared. Now what I'm trying to do here is I'm trying to see, is there a relationship between side A and side D? Is there something that's true about them that might give me more information, that leads me to one of these four congruence theorems that wasn't already there to begin with? So if I get this to say A squared equals, I just move the B squared over here, right? So I'm going to get A squared equals C squared minus B squared. Basic algebra there. And if A squared equals anything, then A is equal to the square root of that anything. So A is equal to the square root of C squared minus B squared. Now real quick, that does not equal C minus B. If you're thinking that, don't do that. I'll prove it to you real quick. Suppose C is 25 and B is 6. Sorry, C squared is 25 and B squared is 16. Right? 25 minus 16 is 9, right? Square root of 9 is 3. Square root of 25 is 5, the square root of 16 is 4, 5 minus 4 is 1. So, not the same thing, but again, that's what A equals. Officially, I should put plus or minus here, but since A represents the length of the side, we put lengths of sides as positive numbers, so I did the positive square root. If I do the same work over there and get that to say D equals, what's going to happen to B squared? Or chop it off, it becomes what?
Negative.
Negative B squared on that side. So D squared equals C squared minus B squared. And if D squared equals that, what does D equal?
Yeah, square root of.
Square root of C squared minus B squared, right? Again, I have no earthly idea what A, B, C, or D equals, right? It has numerical values, but I know A equals this expression and D equals that exact same expression, right? So whatever B and C equal, if I evaluate this and evaluate that, I'm going to A and D are the same number, right? So what I know is in a right triangle specifically, other triangles don't have this property, they don't have the Pythagorean theorem, but only right triangles do. If I get a side-side angle scenario, once two sides are equal to two sides, the third sides have to be equal. And once I know that A and D must be congruent to each other because they're equal in measure, I know that now we got a side-side-side congruence. I could also say side-angle side. Take your pick. There's side-angle side if I'm using the right angle, or side-side-side if not. So either triangle ABC is congruent to triangle, A matches up to D, E matches up to B, and C matches up to F. So ABC is congruent to triangle DEF by either side angle side or side-side-side. Take your pick. Once you get that third side equal, both those are true. If I'm writing a proof, I just pick one. If I got multiple options to choose from, pick one. You don't have to write them all down. But